Good day to doctor. My name is Huey from session 1. Now I will present about my solution to convert audio into image. In this assignment, we need to convert audio data into spatial data representation. We need to design and approve to convert audio data values into spatial data values and display them. So some of the possible solution provided is based on the point-to-point, frame-to-frame, features or attribute, or the combination of the solution. So this is a sample solution given by the assignment. For the sample solution 1, it is mapping from point to point. And we can see that at the output of the image, because it's only a black and white, and the pattern of the image also not obvious and is hard to interpret. And for the solution 2 is made based on the zero crossing rate. It's more obvious than the solution 1, but it's still hard to interpret because it only has two colors. Now I will explain about my solution. The basic idea is to mapping the audio data values based on the frame to frame. So we need to calculate the energy inside the frame and comparing the energy with every frame. And after we have calculated the energy, we can assign the color according to the energy level. And after that, we need to combine all the color channel and display it as an image. This is the flowchart for my solution. Firstly, we need to read the audio file. Then we need to determine the length of the audio and calculate the number of frames. And the window size I set is 256. Next, we need to calculate the energy in each frame and determine the maximum and minimum energy. And next, we need to calculate the threshold for each level. I will explain at the next part. And for the energy, we need to normalize it into the value between 0 to 1 so that it can assign to the color channel. And lastly, I brighten the image by multiplying the matrix by 2 and display the image. So this is the main script. This script I used to read for the audio from the computer. The solution script is the proposed solution I explained just now. So firstly, we need to calculate the number of the frames by using this formula. Matrix X is initialized with 0, single row, and n-1 column. So the energy in each frame is calculated and is stored into the matrix X. And the energy is calculated using the formula E equal to sum absolute Y 1 to P. And after that, the energy graph is plotted. And next, we need to determine the minimum energy and the maximum energy. So to determine the color for each energy, I have divided the energy into 3 categories, which is the low energy multiplied by 1/3. Medium energy is mean the average energy. And for the high energy level, I multiply the sum of minimum energy and maximum energy by 2/3. And next, I have declared the Y matrix. This Y is for us to display, so it means this Y is our image. And I have initialized the Y with 0, and this 200 is the height of the image, and N is the number of the frame, mean by the width, and 3 is for 3 pages. So the first page is to be the red channel, the second channel is the green channel, and the third channel is the blue channel. And this is the for loop I use to assign the color value. In the for loop, I use several if-else statements so that the condition is clear and it can assign the color to the matrix accurately. So when assign the value, I need to normalize it for the value so that it's between the 0 and 1. And this is a formula for the normalization. So how do I assign the color? If the color energy is greater than the high energy level, it is determined at this part, which is multiplied by 2/3. And if the energy is higher than the high energy level, the color will appear more closer to the red color. The color will be brightest when it's at 1. And if the energy is lie between the low energy level and the high energy level, it means between the energy between the area between the low and the high energy. And we need to do further comparison, which is compare the medium energy level. If the energy is higher than the medium energy level, it should be appear more closer to red, the mixture of red and green color, which is yellow. And if it's lower than the medium energy, it should be more closer to the mixture of the green and blue, which is cyan. And if the energy is lower than the low energy level, so it will be blue color. And the last part, I used to display the image, but before I display the image, I have multiplied the image by 2. This is because I need to brighten my image so that it appears more attractive. At the figure below, I have shown the different with or without using the multiplication. So this is the image using the multiplication. Is more brighter and more obvious for user to observe the pattern. And if I do not use the multiplication, it will appear darker. So it's not interesting to be looked by the user. So this is the result for the audio one. The result for audio one is so the energy is higher and the front part. So the front part is more closer to the red color, and here is a medium, so it's more appear to the yellow color or the cyan color. And the last part is less than the low energy level, so it's blue in color. And for the second part, we can see that the signal is higher and it has like higher and lower very frequently. So we can see that the energy that lower is blue in color, and the medium is yellow, and the highest is the red color or orange color here, and finally return to the blue color. And this one is very obvious. The front part is low energy, so it appears blue and cyan color, and is highest when reach this area, so it's red and orange in color, and yellow, cyan, and blue. So the conclusion for my solution is my proposed solution is able to produce the image from the audio signal, and the algorithm I use is mapping the audio data based on frame to frame. And the attribute I use the energy to compare the color, and it can be visualized. Finally, I use the image processing like using the simple multiplication to brighten the image. So I think that's all of my presentation. Thank you.